It gives me pleasure to introduce to the room Florents Tselai, who has been researching AI and other useful things you can do with Postgres for years. And I'm really interested to hear about this system that he's going to present. So please, a warm round of applause.
Okay, thank you. Hi, everyone. Thank you for being here. So that's a very favorite. It's actually the one story, the one application that I'm mostly proud of. It's very impactful, and I've always wanted to present it at PGConf because I've been maintaining this for a few years, and using it as a testbed. It's the one journey that got me from learning more about Postgres to extension development and then into actual contributing to PG Core, right? So the story, this is a New York Times front page on 18th of August, 1991. It's weird because it doesn't mention anything about it, but I was born in that day, so no one recognized it. But finally, the recognition came yesterday by Claire Giordano at If You Were the Talk. So this was the my first core contribution at PG18 a few weeks ago, actually. So this contribution actually started when I started working on Diofanti. So what's the backstory? This is the actual function. I basically added another flag to this JSON-based strip nulls. And we'll get to the story of how everything connects together. So I was born in Albania, actually, but I grew up in Greece. We went to Greece when I was 5 or 6 years old. And then a little bit more technical about me. I work mainly on developing Postgres extensions with C. You may know some of these extensions, and I also presented Spat a couple of days ago at the Extension Showcase Summit. But my background is mainly in data engineering, so I work with a lot of application and front-facing application of Postgres. So these are some of the extensions I have been working on, both in Postgres mainly and some on SQLite and DuckDB. So what is Diofanti.org? It's very simply a BI/GI tool for citizens and taxpayers. It's very powerful, as you will see. So the basic logic behind it is you can go on here, and you can search. You can basically say, that's in Greek, but you'll get the idea. So you can say, OK, I want to search for the decision that the municipality of Athens has done over the last 30 days, right? So it has published around 700 decisions. It has paid out 16 million euros. It has assigned 13 million contracts, and so on. So that's very interesting stuff. So the background is, Diofanti is basically JSON-B plus full-text search in SQL from PostgreSQL. That's 100% what it is about. It has had a very huge impact in Greece, and I'm trying to be modest about it, but it's true in that it's used on a daily basis by investigative journalists or for really hardcore stories. It has been used to uncover anti-abortion campaigns published with public money. It has been used to uncover shady contracts from big co's to the government and have a few of them actually cancelled. And then it's routinely used, of course, by opposition to the government to uncover hidden contracts and so on. And of course, when the opposition becomes government, they take the other role. And the user stories are always surprising. My favorite user story about it is I have a very close friend who I know I've been for years. When she said, OK, oh my God, this is really cool, and she works for a big consultancy. She said, oh, that's really cool. You know how I'm going to use it? I said, how? I will see whether, in case our competitors got actually more government contract than us. So I will go on and complain to the minister about it. So you never know when users, how they're going to use your product. Where does it get its data from? So it gets its data from the Avia. That's a Greek public government initiative. Started in 2011 to answer the basic question of where the money go when actually Greece came at the best moment, right? So when the government went bankrupt, everyone was asking where did the money go? Okay. Okay, we got it. So the Avia was launched in 2011. It has basically one simple mandate. For a government decision to be executed, it has to be published first. Government, speaking with the broader governments, from municipalities to the Prime Minister's office, ministers, and so on. One decision is fundamentally one JSON document / one PDF document, and I'll see how it all started. Currently, the government version of it is based on Elasticsearch, and it has around 70 million decisions so far. That's around 20,000 decisions published per day. How it started? It started with visa problems, right? So I know a lot of people actually miss the conference because of visa issues. There's always a visa issue. So around 2018, we were waiting for my mom's citizenship decisions to be published, right? So there was a dilemma, but this decision could be published anytime. So there was a dilemma, either wait for a 10-year-old for a few days, maybe, or apply for a 10-year visa, which you have to pay a bit more money, which would be in vain in case the next day the citizens will be published, right? So we have to we have to check every day, and you never know what would happen. Unless you are this guy here, who is Yannis, you probably know him. That's when he got his citizenship, just in order to be able to sign as a Greek citizen at the NBA draft. But my mom is not tall enough, right? But she may not be tall, but her son is a geek, right? So I said, okay, can I automate this process? Yes, so can I scrap the Avia and search, basically curl, grep, and search for my mom's name? And suddenly, I discovered that not only I can do that, even better yet, the Avia has an API. So here's an example of a decision as published as a PDF. That's actually a contract, like some money I personally got from the Greek government when I did some lectures at the university, like 2,000 euros. Behind this PDF, there is also this JSON document, which, as you can see, it's extremely powerful in that it has some IDs, it has my name here, and it has the amount of euros. So I said, okay, we're onto something here, and indeed we're onto something. Then I started just scrapping everything and posting it into Postgres. And now you can do search like this one. You can search for my name, how much money have I gotten over the last 30 years from the Greek government? It's like less than 2K. So, and then of course you can do a full text search here, you can do full text search here on the subject, and so on. This is the obvious, like the government's version of the similar app. You can do something, you cannot do anything like it here. It's just keyword-based search on top of Elasticsearch. So it's not really informative, right? So I said, okay, that's interesting here. Then let's get all the data and put it in somewhere. My personal philosophy is always start with Unix tools and declarative SQL and only scale out if you really have to. So the first attempt around 2018, the first version was crawl with curl, some JQ filtering, index to SQLite, and coordinate with makefiles. But it was a bit tricky. So this was one of the first scripts, the first version. You can see for each month, iterate, fetch, there's a shell script here, get the decisions, and so on. And that's another version, another complementary script to that. So, but I wanted to use more SQL for orchestration, right, for the data engineering part. In that case, this is when I discovered, while Googling SQL and HTTP, I discovered this PSQL HTTP extension. Does anyone know it, this extension? Yeah, so this is from Paul Ramsey. I haven't seen Paul around these days. So when I discovered this, I said that, okay, I can select HTTP GET from the database and actually get data from within the database. This minimizes complexity through the whole pipeline as anything else. And then I said, okay, let's use that. But it turns out that the user agent that the curl uses, that Paul has put, it said like PSQL or Postgres something, which is not recognized by the server, so my request will get blocked. Now I find myself going into the source code of the extension, and this is my first ever, I think it's like 60 years ago, yeah, early 2021, that's my first encounter with Postgres extensions. I actually wanted to be able to set the user agent for me to be able to crawl the API as well from within Postgres. And then this is the first encounter I had with C in Postgres and extensions. And now I could do operations like this one. If you know some bash, you can identify that this is not just a script, it's a here document, in that I iterate here over the input of the scripts, and I pipe the whole thing to pSQL. So this is executed within the database. This version here also pipes the result to PDF to text, so I also get the PDF, parse it to text, and then insert it into Postgres. So and then I eventually have two tables. One decisions and now decision text. Decision has raw JSON-B, and the other one has parsed text from PDF, which a few years later got me to create this extension. Maybe you have seen it around. It's a bit popular. It's a bit popular, so it actually allows you to do what you see here. You select a file path, you cast it to PDF, and behind the scenes, it will go on, it will parse the PDF, and you can just extract also some metadata from with it, right, instead of PDF to text. That's very anti-pattern. Whatever I have done here through this whole process, it's wrong. Doing operations within the database is wrong. Parsing PDF is wrong. Putting the database is wrong, but it works. So it's right. So you can also do things like that. And then you can do even more wrong stuff, which is create two extensions, install them both, and then have both PDF parsing and HTTP with that. Or someone would hang me about this, right? Because it's very wrong to do. I also mentioned JQ in the past, earlier, for the filtering. I had some very weird filters to filter out the data, and that led me to build pgJQ, which is it's a small utility that allows you to use JQ syntax instead or in cooperation with standard SQL and SQL JSON as in JSON path in Postgres. So you can do like select JQ with the JQ syntax in case you do something like this. Workflows. So the whole thing goes around the idea, get some JSON, get some PDF, fetch it in the database, right? So I wanted to use the best data workflow engineering tool there is in the market. Can anyone guess what this is? Has anyone used Airflow? Luigi or whatever? Good, that's not the tool I'm talking about. This tool is GNU-make. So you have used this, right? Right, so another wrong thing, right? So the workflow thing, it allowed me to use this in Airflow, they call it DAG, directly acyclic graph in 2010 or whatever. Welcome back to the 1970s, everyone. Right, so this is the process, you can go, yes, okay. This is the process that eventually goes, so here's the target that says refresh, like fetch the new data, refresh the materialized views, and so on. The first step is to get the decisions, index, like for each one decision, get a detailed view, it doesn't matter that much, and then refresh these materialized views. We're talking PG12, so a lot of JSON path was not still there, and you had, for BI purposes, to have materialized views or generated columns and so on. So this was backed by this makefile here. So if you see here, they are in Greek, but it means like decision payments, project. These are the usual business questions that I wanted to have pre-computed and then send to journalists or have them there as well. So this, again, no Python or anything else. This is a sample of the table that powers this thing. It's fundamentally just a data column, a JSON-B column. Is the MongoDB guy around? That's good. So that's how you should do it. So that's the base column, and then metadata extracted from here. And that's the example decision. And this is how it looks like. So this is the primary key, generated column from the JSON-B, and everything else is generated and stored columns, plus the TS vectors for the full text search here as well. Again, as we said earlier, it's just JSON-B plus FTS. It also got me to the process of tweaking a bit the FTS, the Greek FTS configuration within Postgres. I spotted that there were some stop words missing, right? And I sent to the hackers like a few years back, hey, guys, this thing, it's a bit, there are some stop words missing. Can I maybe, change this? And then Peter Eisentraut, he's not around, right? Okay, he's not around. So he was like, oh, not who are you? I was like, for us to change the stopwords, you have to be through the process, who maintains it or not. They said, you know what, I'm not going to do this. I can just create an extension, and I did an extension, which is this one. It is, it's called FTS Greek, pgFTS Greek. And the only thing that it does is actually, so this is the vanilla Postgres version, which, as you can see here, this is a stop word. It's an article in Greek. It should be here. So I switched this to a Greek extra, and it does a better parsing with the stop words. At some point, it reminds me that I have to go back to the discussion with Peter and actually resubmit the patch again. So this yielded me to have another extension with more stop words. So it looks complex. Why? Because I started PG12. 6 years ago, we're PG18 now. A lot of operations didn't exist back yet. JSON table didn't exist. We got JSON table last year, PG17. This simplifies things quite a lot. You can have views. We now have in PG18, we have virtual stored columns, sorry, virtual generated columns, not stored ones. This is very useful as well. Plus, while going and working in this project, I had to learn a lot of things that I even didn't know about, right? Like table spaces, right? So I learned to scale the database at a disk level through table space. I hadn't had the need ever to do something like this, right? But now I learned this so I could just plug another disk on my server and be done with it. And of course, I was lazy to replace already working functionality, even though it worked fast enough with with Unix tools. So today, the whole process is as simple as get a new decision, like launch a few curl requests, index some missing data, and go through the process of getting the detailed view of the JSON, get the PDF text, and fetch it in the database. So I learned more about SQL as going along. And the near future, this is an unveiling, but it's recorded, but it's OK. So the next future is actually going like everyone does, put a chatbot on top of it. So you can have a view like this one. You can just ask it a Q&A. That's a work in progress, but it's almost there. It will be announced publicly pretty soon. And you can do search like this, which means what has the municipality of Athens decided recently over the last X weeks or months. And it does some now pgvector semantic search, and it will answer you a lot of questions. If you want to make friends with big companies, don't do something like this because they will hate you. But hate is going to hate. Thanks a lot, everyone. Here's your feedback. Question, comments? We're good.
I love your Greek IDs, the short keys. How do you generate them? Is it better than UID?
I don't know who had the idea of using Greek, you mean the Greek letters, right? Yeah, it's better, probably looks better than UID. I think there's a special algorithm there because they validate it somehow, like they validate VAT ID. There is an algorithm there as well. I don't think they're random. So there has to be some logic there as well. Yeah.
Also, the Greek alphabet has 2 extra characters compared to Latin, so.
Yeah, but that's a government ID, right? It's uniquely identified across the government, so it has to have a unique ID for it to be executed from someone, unless someone goes, to jail or whatever. Anyone else? Well, thank you, guys. You can post your good or great feedback here. Thank you.
Thank you.